Hey everyone, welcome to this talk about what I call the democratization of software development. First, a few words about me. My name is Max, I'm from Switzerland. I've been in software development for, I've been in software development for over 15 years now, most of this time in web development and more specifically in front-end development. Nowadays, a lot of the work I do is involving AI in some form or the other. I would love to connect with as many of you as possible today. To do so, you can find me under my name on LinkedIn or under this handle on X or Twitter or whatever you want to call it these days. Now, I'm an engineer at a startup called Sutro, where we develop the next generation of a no-code builder and enable non-technical people to build apps super quickly. So here's how this works. You start with a simple prompt, an idea that you have in mind. An AI assistant helps you to refine this idea just a little bit. And as soon as you're done, the AI assistant is going to build the initial version of your app. And now you are in this no-code place, like a typical no-code environment right here, where you can make all the customizations to your app. And as soon as you're done, you could just hit publish, and we publish it for the web. We publish it for iOS and Android platforms, all of that. Now, this talk covers like the future of how software is built. And obviously, I'm a bit biased because I'm working for a no-code builder, but this is not an ad for a product. Instead, it is really, I will just demonstrate all the learnings that we had and how we think that that software will be built in just a few years' time. To talk about the future of software development, we have to start with the history of software development. And what this really is a history of abstractions. Because, as you know, in the end, every single computer program is ones and zeros that run somewhere on a processor. And I'm assuming none of the people in this room operate on this level. All of us operate on some kind of higher abstraction, right? So in the early days of computing, the first programs were written using physical punch cards. And each card was representing a single line of code. And developers punched holes in specific positions on each card to represent different instructions and data, encoding them in binary format. Then you had to feed those cards into a computer, and the computer then executed the corresponding instructions. Of course, it required precise organization, as even a single misplaced card could cause errors in the program's execution, and you would just have to start all over again. Later, we got assembly. Assembly is already an abstraction over the machine code, and for a while, it was the quickest and easiest way to write computer programs. And fun fact, the guidance control computer for the Apollo missions, which brought the first humans to the moon, that was all written in assembly. Here's a quick example of what assembly looks like. Do any of you have an idea what this code might be doing? Yes? So what it does is it just calculates the sum of the numbers from 1 to 10, and it prepares to print them, although to really print them to any sort of console, we would need a lot more code, which doesn't really fit on one slide. So assembly language allowed developers to use human-readable symbols to represent machine instructions. It made it slightly easier to program by reducing the need to write pure binary, but of course is still very low level and also hardware specific. And the problem with assembly was that it required deep knowledge of the hardware of computers, and code written with it was not portable at all. Now, after that, eventually we got the first high-level languages like Fortran, COBOL, Lisp, etc. Those allowed developers to write code much closer to human language and abstracted away all the hardware specifics. Now, for the first time, you could write programs and actually run them on different architectures. So this increased productivity, portability, accessibility, and it also enabled more complex applications. And a fun fact, a lot of those languages are still very much in use, for example, in banking environments. The problem with those earlier languages is that they often led to what we call spaghetti code, which was super hard to read and maintain. So the next thing we got was structured programming with C, Pascal, and those kinds of languages. And those introduced clear logical control structures such as if-else statements, loops, and callable functions. It improved code readability, it reduced errors, and it set the stage for modular programming practices. But even structured programming had its set of problems. The larger that code bases became, the increasingly harder they became to manage and scale. That's kind of when object-oriented programming started to be a thing with languages such as C++, Smalltalk, or Java, which introduced the concept of objects, encapsulation, inheritance, and polymorphism. It simplified code organization, and it made code more reusable and laid the groundwork for modern software architectures. Now, in the early 2000s, we kind of saw this new generation of apps built on this new web platform. But because web development was really difficult to do with languages such as C++, there was a wave of new languages and frameworks that sped up web app development. And those languages and frameworks provided reusable components. They provided abstractions for databases. They simplified state management with session variables, etc. And kind of just made it easier to actually write large-scale web applications. Now, yeah, a lot of those early web frameworks, they were like mostly back-end focused, but at the same time, or around the same time, we also saw the emergence of this new language called JavaScript. Now, JavaScript is a higher-level programming language that was supposedly created in 7 days and shipped with the Netflix Navigator. It is a simple language. You can learn it super quickly, and you don't need to worry about things like memory allocation or garbage collection, all of that. And so initially, it was just meant to add like a few simple interactions to web pages. But since then, it kind of grew into this new, bigger language of its own. And it is in very active development, and the JavaScript language receives meaningful new features every year. And yeah, JavaScript is cool, I think, because it's super easy to learn, and you can now easily achieve things that were previously just like required very specific knowledge about certain technologies and environments. That's why like a lot of companies started using JavaScript to build like abstractions for other platforms. And I'm going to show you a few examples. All right, so we have with Node.js, we get JavaScript on the server. While initially it should just be running in a web application or in a website, now we suddenly could use JavaScript on the server as well. And with that, we don't really have the need to use another language such as PHP or .NET. And web developers can now build frontends in the same language as their backends, which is cool. And then at some point, we saw this framework called Node WebKit, and then later Electron, and now Tauri. And all of those, what they do is they enable JavaScript developers to develop native desktop applications. And they can use specific high-level APIs to integrate with platform-specific features, such as accessing the file system or showing notifications. So basically, everything that you could do with like in a modern desktop application. Now, at some point, we got React. React was kind of an important milestone as well because it now enabled developers to build more complex front-end applications. React was created by Facebook, and it's powering the Facebook and Instagram web applications. And it is a JavaScript framework that adds a new syntax, but really what it is, it's just another abstraction on top of JavaScript. And this was super revolutionary at the time because yeah, it just made it easier to build like larger web applications that was previously not really possible. You had things like state management, updating UIs, and all of that, right? And then we had Next, which is even another abstraction on top of React. It is a so-called meta framework for React that even more simplified specific things like route management, but also server-side rendering and like clear separation of application logic. And this is now, I think, Next is now one of the most popular web frameworks out there. And I would guess that like at least half of new Silicon Valley startups probably use Next for their apps. But it doesn't stop there. We also got React Native. And with React Native, you can now run React and JavaScript on mobile. So this is another abstraction which enables developers to develop apps for platforms such as Android and iOS. And unlike PhoneGap, which previously already made this possible to like develop apps using HTML, CSS, and JavaScript, apps built with React Native are like actually native apps. They don't just render a web view and web components in there, but they reuse the actual building blocks of native applications. And they are much more accessible. Yeah, this was obviously a big milestone too, because like those companies, Meta, they didn't need specific iOS and Android engineers anymore, or a lot less of them. And they could suddenly reuse a large part of their code base. And today there's so many popular apps that are built with React Native, and it's just really a super easy way to target multiple platforms at once. There are even official and unofficial parts of React Native for platforms such as smart TVs, VR environments, or even cars. Now, as you can see, since the beginning of computer programming, we kind of started building higher level abstractions. And each abstraction made it possible to write software that was previously either not possible at all or just way too much work. And obviously the cool thing is that all of those abstractions can like be combined in various ways as well. So for example, if you are writing a desktop application using Electron, you can also make use of React, which makes it a lot easier to build complex apps. And most web apps, either built with Next or any other framework, they also make use of ORMs typically, which are also just an abstraction for databases. And what I think is the coolest thing about all of that is that with each abstraction that we introduced, there's a whole new generation of software developers that are entering the market. While there were only a handful of engineers back in the times of punching cards, we now have like millions of software engineers building cool things today. So at this point, let's talk about AI. I'm sure every one of you has, well, at least tried ChatGPT or maybe even built something with AI yourself, maybe even fine-tuned your own models. AI has taken the world by storm, and it's widely used by almost everyone in almost every sector out there. But we have to remember that we are still very early to this. So ChatGPT only very recently celebrated its 2-year anniversary. So still very young. And yeah, the acceleration is real. We have so many advancements. Dario Amodi, the CEO of Anthropic, says now that if AI development continues at this rate, we could already see AGI in as early as 2026. And with the release of OpenAI's new O1 model, AI can now solve problems that were previously just not possible at all, and in many cases is better and faster in like problem solving than humans are, expert level humans are. Let's talk about AI in software development. Now, all of us in software development, I'm sure, are using AI in some form or the other, with the most used AI dev tool right now probably being GitHub's Copilot, but also alternative editors like Cursor. So what they are doing is basically they are coding assistants that are built right into your code editor, and they can answer questions about your code bases. They can help you find errors in your code. They can help you write completely new code. Another great tool for developers is Vercel's V0, which is very nice. So you can just kind of describe what kind of front-end component that you need, and it will build it for you in a very nice way. Now, we talked a lot about abstractions in software development. But in general, we can say for each abstraction, and an abstraction can really be like either a language, a framework, can be a library, it can even be a tool. We can specify on which level it operates. So we have a development time, build time, runtime, right? And so at runtime, that would be like specific runtime environments, such as the JVM, which Java and Kotlin use. Or it could also be like a browser-based JavaScript environment. At build time, we have things like, for example, Webpack that bundle and minify all the application code, or maybe even things like Rust-specific checks for memory safety. And there are other libraries like TypeScript or specific coding linters, which also run at build time, but usually you can use some sort of plugins that really help or notify the developers during development time. And where do all of those AI and software development tools fit in? Well, right now, all of those fit in kind of this layer of development time. This means they just help us produce or write code. Right? You can talk to ChatGPT or you can talk to like your Copilot, and it just helps you to understand and write the code that you were already writing before. There are now a bit more advanced AI systems that are usually using agents, which can produce code that spans multiple files, they can even build like initial fully working versions of your front and back end code. But at some point, usually it becomes quite difficult for an AI to work on like a larger code base. It's basically the same for humans as well. I'm sure if you've all been at the point in your career where you joined a new company and it just took you months to navigate the code base, which was often like distributed into multiple services, multiple microservices, multiple code bases, just missing or wrong documentation at all, right? And this is hard for humans. It is very hard for AI as well, currently. Now, while modern like AI assistants usually operate at development time, I could imagine that at some point in the future, we could also see like AI-based compilers or runtimes too. Who knows? But anyway, here's the thing. With all of those AI tools for developers, code gen and AI agents, they still need to be used by a software engineer who at least has some basic knowledge about software architecture. And as we've said before, the larger your code base becomes, the more difficult it becomes for an AI to produce like working code as well. So you still need an engineer to work together with the AI. It's really just an assistant right now. But so what about all the non-technical people that want to build software? Well, that's where no code comes into play. Let's maybe quickly start with the definition. So there are different flavors of what we call no code. And I'm really just going to be talking about two of them. There's like specific sub-flavors and everything, but we're going to be focusing on no code, which means building apps without writing code, using drag and drop tools, and it's ideal for non-developers. And then we have low code. Low code means like the combining visual tools with some coding for faster, flexible app development suited for developers needing customization. Or maybe even some developers, some non-developers that have a lot of like technical understanding. And like no code really started in the like very early in the 1960s and 70s. We had the first visual programming languages which already emerged. They introduced graphical elements to represent code and thus simplified programming concept. And those early languages kind of laid the groundwork for the no-code movement that we see today. I would say another milestone, which was in the 1980s, that we got the first version of Microsoft Excel. And Excel kind of transformed data management by allowing users to perform complex calculations and analysis through a spreadsheet interface. With its use of formulas and macros, it enabled automation and data manipulation without the need for conventional programming. And so it kind of, you could see like this is like the early no-code or low-code environment. A bit later, we got Microsoft's Visual Basic, which is really like a programming environment, but it made it super easy, and it provided like a graphical environment to help with the application development. So you had like a drag and drop design for user interfaces, and like it reduced the amount of code required, and it lowered the barrier to entry for software development, and thus marking like a significant move toward low-code solutions. Now in 2003, once again, with the emergence of this new web platform, we saw this WordPress framework, which kind of democratized web creation really by allowing users to build and manage websites without coding experience at all. Its extensive plugin and theme ecosystem facilitated customization and functionality expansion. becoming a foundational tool in no-code web development. There's so many people out there who suddenly they like had no programming knowledge at all, but could like have their own website and start publishing their thoughts and all of that. And all that led to like the modern no-code platforms that we see today. That's like Bubble, Webflow, and Zapier are probably the biggest ones. And these tools really enabled users to develop complex web and mobile applications, designing responsive websites, and automate workflows without writing code at all. So this movement has significantly expanded access to software development, empowering individuals and businesses to really innovate rapidly. And it has to be said that in many cases, using no-code tools today is a lot faster and cheaper than working with developers. Now, let's get to the future. How will the future of software development look like? Well, I think neither code gen, like AI code gen, nor no code alone will be the future of how people create software. So, because both of those have kind of their like downsides, right? So with code gen, as we said, it's really easy to get started. Like an AI can help you build your very first version of your app, but then it just gets exponentially harder to scale in larger, more complex code bases. And no code, well, for most platforms, this is really just another way of writing code. Like tools like Webflow, for example, all they do is they produce code in the end. They offer like an alternative way of producing this code. Most of those no-code tools don't really have an inherent sense of application logic. And a lot of those no-code tools that we see today are considered rather to be expert-level software. So there are now a lot of people out there who call themselves Webflow engineers or Bubble developers, which is kind of ironic, right? Because they are supposed to be like the pillars of the no-code movement. So we talked a lot about abstractions today. So I think what we're going to need eventually is we're going to need new abstractions. And current programming languages like JavaScript or like the React framework, they are kind of the best thing that we could come up with for developers, but they may not be like the optimal interface to operate with LLMs or other kinds of AI. So I really think new high-level abstraction languages are needed. Also, I think those abstraction languages could combine multiple parts of the architecture, right? It could combine UI and application logic, but it also could, like in the future, it could combine even more. It could combine like the hosting, maybe business environments, all of that. And with such a new high-level abstraction language, I think it will be like a lot quicker to build like kind of like simpler functionalities. But of course, it would also need to be possible to extend it and like super customize it wherever possible. And I think a good comparison for that really is how Markdown works. So Markdown is like this high-level markup language, which makes it super easy and quick to write documents with like basic formatting. And in the end, it just compiles into HTML. And of course, you cannot do everything in Markdown, but it's not really needed because in Markdown, you can still, because it's like a high-level abstraction for HTML, you can still use HTML and JavaScript and CSS, right? So you can write like 80% maybe of your document just using Markdown, and then have like a few specific components that are like customly developed. I think it's not just about code though, right? So code is only one part of a product, of a startup, but there's usually a lot of different stakeholders working on a product together, such as PMs, technical managers, but designers, and so on. And right now, all of those stakeholders speak a different language. The programmer understands code, designer understands design, the PM uses use cases, and the growth manager talks in metrics. And because you have all of those stakeholders working together right now, there's a lot of time being spent just translating between the different languages that all of those are speaking in, are understanding. And what if this new hypothetical high-level abstraction language could bring together not only developers, but builders in general, designers, marketing people, and so on? What if all of them could work on the same definition of an app all at the same time, basically on the levels that they are concerned with? Feedback circles that we have like right now, there's a lot of going back and forth, right? They could become way less and way quicker, and I think this way startups could bring their first product to market in weeks instead of months or even years that it takes now. And it's really not just going to be like, it's not just an AI that helps you build like a product or build like software. You could also have like an AI designer built in, right? An AI designer that's like provides super beautiful designs. Then you could also have like an AI product manager, AI growth manager, AI marketer, all of that basically built in, right? All in one platform. And instead of using AI to just build your product, like your initial product, what if this was more of a continuous process? While AI, like when AI gets access to usage data of the app and business analytics and stuff like that, then it might become possible for it to suggest and improve and implement improvements by itself. And so this way you could really give the software or the AI a guidance metric, such as a number of signups, page views, or even MRR, and it would do everything by itself to try to improve this one single metric. Yeah, of course, that's a lot of hypotheticals about the future, and it's probably I don't think we're going to be there in the next 1 to 2 years, but this is going to be like 5 to 10 years out. What does that mean for us as software developers today? Will we all lose our jobs? If you ask me, I would say no, I don't think so. But obviously, a lot of whoever you ask is going to give you a different answer. I think you're not going to lose your job, at least not in the short to midterm. But there is this quote that I very often see pop up, but I have no idea who the original author is. It goes like, will AI take away my job? I said, no, but someone using AI might, right? So at least right now, AI is here to make us more efficient. And of course, that also means that if your competitors are using AI and you are not, they can potentially do the same work better and cheaper and faster than you can. But if we look more into the future with the abstraction level like getting higher and higher and the learning curve lowering at the same time, I think it might become mandatory for developers to specialize in something super specific. I think there will probably be less need for junior developers because all of the easier parts of the software development will be automated, but at the same time, the demand for highly specialized senior engineers will grow a lot just because a lot more people are going to be producing software, right? And so this is really what I think is going to be like the democratization of software development. The barrier to entry to build software will continue to get lower and lower. And this is a good thing. Because just think of all the people who have good ideas right now, but just no way of implementing or realizing them themselves. Because here's the thing, right? As developers and as humans in general, we tend to solve our own problems. That's why there are just so many startups just around dev tooling. There's so many startups just about like using AI for software development. But just imagine what other kinds of problems will be solved by people who just don't really have the means to do it today. Before we end this session, I would like to give you some takeaways and recommendations for the future. The first one being like become familiar with the newest AI technologies. There's so much going on. There's just so much development that we're seeing. There are new and super specialized models being released every day. We have like spectacular level breakthroughs every 1 to 2 months now. And I think for us, it's just important to watch the space and learn about the possibilities that all of those new models bring. Also, I think it makes sense to implement some AI-based workflows right now. So, for example, Cursor, the code editor, is just really, really good, especially with the new Claude 3.5 model by Anthropic. But also just GitHub Copilot is really good too. And OpenAI's O1 can help us solve really complex problems. So here's just a small personal anecdote. A few months ago, I built a Vision OS app for the Apple Vision Pro. And I did that only with the help of ChatGPT, right? I have never used Swift before, and I could achieve all of this in a day, like a working app in 1 day. Another thing that I would recommend you to do is just to go out, try to build something with AI. Like all major AI providers like OpenAI and Anthropic, they provide APIs for to use their models. Also, make sure to check out frameworks such as LangChain or Llama Index. And yeah, it's really never been easier to build like smart, intelligent applications. And last but not least, tell those family members of yours who always have like an interesting app idea that they pitch to you during a Christmas dinner about the latest no-code platforms, such as Sutro. And yeah, their chances really are that they can already build their ideas just on their own, and you don't need to do it for them. Maybe a last word about Sutro. Our mission is to build like this next generation of no-code platform that brings together builders and designers and product managers and everyone else. And yeah, we are not there, like what I talked about just now, but we already have a first initial version that we launched just a few weeks ago. And with it, you can already build fully functional apps in literally minutes. And right now we are working like very hard to make it possible to build more customized and more complex apps with Sutro as well. Yeah, feel free to give it a try, and let me know if you have any questions. Thank you very much.